were looking at, it was more like y equals a times b x minus h. Okay, like that. So here, like the a is kind of similar. What you put in your equation is the initial amount in any of these word problems we do. The rate should be shown as a decimal. So for instance, if it's like a 8% interest rate, when you put it into your formula, you put it in as 0.08. So whenever you see that percent sign, convert it to a decimal by moving your decimal 2 places to the left, and then time. So exponential decay is the exact same formula, but with a minus sign. That's when something's decreasing. And then compounding interest is really a finance application. So we'll be using this tomorrow and the next day when we work on our credit card project we're going to do. What banks did to get competitive with one another is they agreed to give people interest more than once a year. So, like Bank of America might give you like 4% to save money in their bank, but Wells Fargo says we'll give you 4% too. Like that's what's competitive, but we're going to give you interest monthly. And so they're going to get that rate. They're going to divide it by 12, and they're going to give you a little bit of interest every month. So that means in 1 year, they're not just they haven't just paid you interest once. They did it 12 times. So whenever it's compounded, you put that amount in here and here. And so at the end, if they're giving you a little bit of that same interest every month, it'll grow a little bit more. It'll be a little bit higher. So if they said we're going to compound interest weekly, we would put a 52 in here because there's 52 weeks in a year. You guys know what annually means? Once per year, semi-annually, twice per year, quarterly, 4 times per year. So that's all like vocabulary with these finance word problems. All right, let's try. So I'm going to give you a word problem now that goes along with that first model. So this is growth. It says the population is expected to grow. So you're plugging this information into this first model that you wrote down. You do need a calculator. All of these problems are meant to be used with a tool. They're not meant to be done by hand. You need a calculator tomorrow and the next day for classwork. Please bring a calculator. There's a lot of decimals, a lot of rounding. It's best you practice it yourself. Don't wait for me to put the number up. Actually calculate it yourself. So in 1997, the bear population the population began at 87 bears. What will the population be come 2027? So our initial amount is 87. That's what you put in for the A value. We'll do 1 plus, we don't put 2 in here, we put 0.02. And then for time, it's what?
1 year.
It's 30 years. 30 years between 1997 and 2027. 30 years go by. What will the bear population be? So they're hoping that this bear population is going to grow. Trying to save the species. So there's a 30-year outlook. For things like people and animals, we're going to round to the nearest, well, you round up to a whole number. We're going to go right from bulwark into classwork. So any of this could go into bulwark. Just do every problem. Well, don't put it in there like that.
We can copy that down or just get the answer?
Just get the answer. Try to put it all together. No, here. We'll do it one step at a time in your calculator, and I'll help you. Put this all in your calculator like this. Or you can go ahead and make it 1.02. But so PEMDAS says that you do the addition first, and then the exponent, and then multiply by 87 last. Oh, yes. I just wanted you to see that you get all of us out of the video. I don't want you to So it's approximately 157.59, let's say. So we don't say there's 0.59 bears. We're going to say in 2027, it is predicted there will be 158 bears. Almost doubling the bear population. All right, so now I'm going to do a word problem for DK. Who's got a question about the calculator? Okay. What's something that decays naturally? Anybody? What? Yeah, let's do a different problem. I'm gonna make this up. This 2% thing actually came from a real part. I'm marking it right now. I'm gonna put it up. In 2000, the bird population is 1,037. If the population is decreasing 3% each year, how many birds will remain in 2030? Put your phone away out. Your calculator? You guys have a calculator tomorrow. So our initial amount is 1,037. We'll do 1 minus 0.03 to the 30. So this is kind of important. So when you subtract, you get 0.97. So if you were here before, I can observe base is less than 1. The base b is less than 1. That's what makes this decay. So when we looked at all the different graphs and we had a fraction in the, we called the 1 decays because the base is less than 1. So this 1 minus takes it to 0.97. So each year, 97% of the population is left. 97, 97, that's a decay. Anybody get a number out, a whole number for these birds? No. 116. Okay. 416 is absolutely right. So the number you should have gotten looks about like that. We'll round it. So, less than half, 30 years later, in 2030, 416 birds will be left. Better get them in a sanctuary. All right, last one, and then we're going to look at some word problems that the textbook writers wrote, something more formal. I just wanted to give you an example of each one. Your company invests $25,000 in an account, earning 3.25% interest compounded weekly. How much will be in the account in 8 years? $25,000, 3.25 interest compounded weekly. So the model I had you write down looks like that. That's how we do it. The interest is spread out over 52 weeks, which means in the 8 years, the bank isn't giving you interest 8 times, it's giving you 52 times 8. Now that one's a lot more complicated to put in your calculator. But if you have the right calculator, you don't even have to hit enter more than once, you can put it all in at the same time. So for money, I want you rounding to the cent every time. I mean, unless the problem says otherwise. Oh, I did 2,500, not 25,000. Someone got a question about their calculator. 25,000 to 32,000 is pretty good growth. Just to put your assets right there in that account.
I got a different. I got 300,000. Hmm? Oh, okay.
Okay, using your calculator. Who else has a calculator question? No? Okay. Alright, so now we're going to look at some more formal problems written by the textbook. The first one's a graph. I'm going to ask you to graph once today. It's right here. Alright, I'm not going to do these for you. I want you to discuss this with your group. Try to come up with an equation. After I hear you talking about it and writing an equation, then maybe I'll show my equation. Yeah. And then for your graph, this is going by ones and this is going by tens. Draw a quick sketch. It doesn't have to be perfect. But members of an online arts and crafts club have been increasing 20% each year. The club is starting with 40 members. I want you to write the growth model for this. It doesn't say it here. I'll say it. Write the equation for this, then complete the table and make a graph of predicting the number of members in the online club. Growing 20% each year. I'm seeing a great equation so far. Good job. Yeah, this will be considered number 7 in your classwork today. And you're going to have time to finish your assignment class, so you won't have homework today. We're going to do 3 more together and then 2 for your assignment and we're done. 5 problems, you guys. 5 problems. You can do it. Call it classwork, but know that it could be on a Bellward quiz, you know? You know what I mean? Keep it going. Here's your equation. Begins with 40. 1 plus 0.2, all raised to 10. So years 0 and 1 are done for you. I'll put a 2 in for time. And then for year 3, I do it again. But I put a 3 in for time. And you calculate your 2. You have a calculator?
Huh?
You have a calculator?
Actually, yeah.
You calculate your 2. You guys, for people, we're gonna round up. Always round up.
Wait, you think it's a-
0.1. Round up. Even if it's a newborn baby. Round up. Tenth of a person? You do number reading? Why not? You don't know how to do it?
Yeah.
Type 40. 40. It's type in your calculator.
Yeah.
Correct.
It's 20.
1.0. Melissa? This is number 7. Same. We're working on it. We're multiple years on that table.
Oh, so that was.
That's part of the answer. So we got 57.6. We're gonna round that to a 58. And now, if you go up and you highlight that and hit enter, it'll bring your equation down, and you just have to change the exponent. I don't like how it goes up by 12 and then like 13. And then 99.5. So in year 5, the Arts and Crafts Club has 100 members. How cool. So the graph, if you do ones on the bottom and tens on the top, I don't really love it because you can't see the curve. So when you connect it, if you do that way, try to like emphasize the curve. So like year 0, they had 40. That's when they started. Year 1, 48. Year 2, 58. Up to 70. 83. And then 100. So those are your curves. Two more problems on here, and then you're done. Nice graph. Get your table worked out. How are you doing the problem? Nice graph. Nice graph. Oh, you were. Ready for the next one as well? Alright, you guys want to take a picture of this? I'm going to move on. You good? Okay, move on. Alright, that's it for drawing a graph. Okay, tennis shoes. The cost of tennis shoes increased 5.1% every year. How much is a $50 pair of shoes going to cost 25 years from now? So you can get a whole degree in finance, and it could be your job to study how prices are inflating. And not everything goes up the same percentage. Like, technology increases at a higher rate than food. Technology increases at a higher rate than like anything, except for maybe like prescription drugs. I don't know about medicine. But medicine has to increase differently than fashion items like shoes or cars, farm equipment. All of that stuff increases differently. And then financial advisors will analyze that as compared to how people's salaries increase. And if people's salaries aren't increasing at the same rate that prices are increasing, that's when people get really upset. And there's unrest in society. And that's when you have problems with your government. Civil unrest because prices aren't matching salaries. They start to question everything. All right, I'm gonna call on somebody. Brian C. Brian C. You think you can write the equation? Let's hear it. You got it. You got it. Yeah, we can go. You're gonna move it too, so it'll be like 2. That'll be your rate. Let's hear it. Yep. Very good. How much are these shoes gonna be? Something number 8.
You ready?
What's that? 25 years over from 50 to 173. Can you guys think of anything that you think the prices might be going up that quickly for? Have you witnessed any price increases in your lifetime? Do you have any examples? Oh gosh, just like in the last 2 months. It's almost nearly double. It was 2 and now it's 4, right?
Yeah.
So it's almost nearly double. So that's gonna work with me.
I think it's like 7.
Well, it started higher, you haven't worked enough. Housing prices go up more quickly than this. Good one, you guys thinking again. Okay. Last problem. It's got an A, B, and C. So, okay. Sam open a savings account on compounds interest at a rate of 3% annually. Let P be the number of P the initial amount Sam deposits, and T be the number of years. Write an equation. Okay, so if you use the model from notes, this problem wants you to use a big A, a capital A for the account money, a capital P for the initial amount. Okay, so it's just kind of challenging you to use the different variables. So the equation you should be writing is big A equals the principal 1.03 to the T. Sometimes it's shown that way. Instead of Y, they use a capital A. Oh, yeah. So because of the word compounding, you guys really should be thinking of that third formula. Right. So because it says the word annually, you know how many times a year that is? It's actually just once a year. So and that's why I didn't write it here, because it would be over 1 and 1 times t, which doesn't change anything. So whenever it says annually, it's really just the same as a regular growth, even though it says the word compounding. You don't have to include the over 1 or the 1 here. It's only if it's monthly, weekly, daily, something like that. Okay? B and C. So the problem looks like this. How much will Sam opens account for 500 and doesn't do anything? How much will be left in 10 years? And then letter C is the one I'm really interested in seeing you guys do with your calculators. So I'm gonna wait. A was just to write the equation. So you could just have this for A. What I just circled. Isabel, what's the answer? 500 at a 3% interest for 10 years. You're just winging it? No calculator? Hannah, do you have an answer? No? You have a calculator. What comes after the 5? So an answer. So in 10 years, there will be $671.96. Did anybody else get that same number? Yeah. I did. Now C is the one I'm most interested in. How long will it take for the account to double?
To double 500 or to double 600?
Double 500. So this is what we're working towards the end of this chapter. So for something like this to double, we would plug in 1,000 here, and we have to figure out. We would put the 500 here, the 1,000 here, and we'd be figuring out the exponent, solving for an unknown exponent. To solve for an unknown exponent, you use a logarithm. So at the end of the chapter, we're going to revisit these same questions and use logarithms to find exponents, to find how long until Sam has earned $2,000? And then you can use a logarithm instead of the guessing and checking you guys are doing right now. You're guessing and checking, right? Plugging and checking. Anybody, what'd you get? Yeah. So, yeah, we'll go to 24 years. The account will reach $1,000 in 24 years, or 23 and a half, but we're going to go to the nearest whole year. So that was found using this equation and guessing and checking. Guessing and checking until we got over over 1,000 here. Soon, in a couple of weeks, you won't have to guess and check. I'm going to show you the method for solving for exponents. Okay, that's it for classwork. Your assignment is just page 92, 7, and 8.